For centuries, this strange star, Tabby's star, has been getting less bright. Some people think that an alien megastructure could be in the way. If you want to learn more about astronomy and futurism, make sure you subscribe and turn on the bell notifications so you don't miss anything. What did Kepler find out about Tabby's star? Tabby's star is named after the astronomer Tabitha Boyajian, who was the lead researcher and author of the paper Where's the Flux, which was given because it provides the acronym WTF, which stands for something else, as I'm sure you can recognise. This was given to the star because this is what everyone was thinking at the time. Anyway, Tabby's star is located 1,280 light years away and is one of the many stars that the Kepler Space Observatory has been studying for many years, and unexpectedly in the past few years we noticed that there were some very strange dips in its brightness that cannot be explained, only because there is not enough evidence for any one of the possible explanations that we will discuss today. Many years ago, astronomers were thinking, what if the computers get something wrong? What if they miss something important in the data from Kepler? So astronomers launched a citizen science project called Planet Hunters, so that instead of all the computers finding all the planets, humans could do the same as the computers using the data from Kepler. And it's not a private operation either. You yourself can go onto the website, just type in Planet Hunters, and you can start going through and looking for transits. I find this pretty cool because it allows the public to be involved with the search for exoplanets, and if it wasn't for the public's help, then they wouldn't have came across Tabby's star. Anyway, talk about Tabby's star began in May 2009 when the Planet Hunters started talking about a dip in brightness from Tabby's star. This dip could only be caused by a planet the size of Jupiter, which is completely normal, nothing strange about that. What was strange was that this dip lasted for almost a week, while dips usually last for only a fraction of a day, normally just for a few hours, meaning that this dip is huge. Not only that, but as you can see from the chart here, the dip in brightness is asymmetrical, or not symmetrical, unlike normal dips that have an almost perfect U shape. This suggested that the object that blocked the star was not spherical like a planet. After that, apart from some dips, Tabby's star stayed pretty quiet until March of 2011, when we saw a massive dip in brightness of about 15%. That's crazy compared to the 1% caused by a planet the size of Jupiter, so it must be huge. The curve is described as smooth and clean, and like the dip in 2009, this is also asymmetrical. It has a slow and gradual dimming, lasting almost a week, and then in a matter of days it shoots sharply right back up to the star's normal brightness. And again, it's a while before something strange happens until February of 2013, where we get loads of really peculiar dips. Unlike the previous dips seen before, these dips happen over a course of 100 days, some of them lasting for a few days, while others more than a week. Each of these dips are different, each with a different shape, some are broad, others sharp, and the length of time is different for each one as well. But this time the star goes more than 20% dimmer than the usual brightness, meaning that whatever is blocking this light has an area of 1,000 times that of Earth. And there are also times where, within a dip, the brightness goes up and down, which seems to suggest that there are more than just one event occurring at the same time. Some of you will have noticed that each main dimming event happens about every 2 years. One in May 2009, the same year as the Kepler launch, then March 2011, then February 2013, then we missed the one in 2015 as Kepler had some technical problems, and then the most recent one in May 2017, which is only over a month ago at this time of me recording this. And as expected, Tabby's star dimmed again, reported from many astronomers, and this sparked lots of other people around the world to observe Tabby's star. Surprisingly, this was the first time we were able to observe the dimming from start to finish in real time, and from this we were able to gather lots of more data about this star. At first glance, it does seem like there is some kind of pattern, because it's occurring about every 2 years, but with further investigation, there hasn't been any sort of regular periodic pattern, which I discussed earlier as one of the necessities. You may be wondering, so what if there is no pattern? Well, if there's no regular dimming, it seems to suggest that this object, whatever it is, does not orbit the star, but at this point in time it's still very unclear. It also means that it's difficult to predict the next dimming event, so when the next one does happen, then everyone might be off guard and not get a good look at it. But I've just been talking about the dips in brightness that have happened fairly recently. One researcher announced in January 2017, this year, that Tabby star has been getting dimmer overall since 1890. This was based on comparing today's brightness to old photographs. This might not be true though, as there is a lot of room for mistakes. But then other organisations checked with more recent data from Kepler that has been collected in the past few years, and they found that Tabby star had gotten dimmer overall by 1% in the first 3 years of Kepler observing it. As I explained earlier, 1% is a massive amount of light being blocked. At first look of Tabby star, astronomers thought there might be some kind of error with Kepler's detection. They checked over the data really hard and found no mistakes, meaning that it was astrophysical. Something was physically out there causing the dip in brightness. And so naturally explanations came about. Now let's have a look at these explanations. There are loads of explanations for what's happening. Perhaps the most popular and favoured explanation is that the cause of the dimming events is some sort of alien megastructure, perhaps currently just being formed or being formed since 1890. When the idea of an alien megastructure was suggested, a joke started to get passed around the astronomical community, with people saying, "We're not saying it's aliens, but it's aliens." The alien megastructure could be something called a Dyson swarm or Dyson sphere. Personally, I prefer the name Dyson sphere. I'll come back to the Dyson sphere in a minute or two. The concept of a Dyson sphere comes from the Kardashev scale, which is a way of measuring how technologically advanced a civilization is, based on the amount of energy available to them. A Type 1 civilization or a planetary civilization can harness the total amount of energy from their home planet. Carl Sagan said that here on Earth we currently are a Type 0.7 civilization. I'm quite skeptical about this estimate because to harness every last single bit of energy we would need to capture every last bit of sunlight and solar panels, collect every bit of wind, collect every wave and tide, etc. And I don't think we're anywhere near that. A Type 2 civilization, or a stellar civilization, captures the total energy output of their home star. This is where concepts like a Dyson sphere come in. A Dyson sphere is a hypothetical megastructure that completely surrounds a star, capturing all the available energy from it through the use of solar panels. It was first proposed by Freeman Dyson in 1960. There are other concepts such as the Dyson swarm, the Dyson bubble, the Dyson shell, and the Dyson net, but they're all around the same idea of capturing all of a star's energy. A Type 3 civilization, or a galactic civilization, is able to capture all of the energy from its entire galaxy. A Type 2 civilization is far-fetched enough, never mind travelling to every one of the 100,000 million stars in your galaxy. It is interesting to think about though, and can spark a lot of science fiction. One way of capturing all of the energy from our entire galaxy is to put Dyson spheres around every star in your galaxy. This seems highly fictional at a glance, but it does seem plausible the tiniest amount when you consider generation spaceships that could sustain life on the ship long enough for it to reach exoplanets to colonise, and then when ready it would go to another exoplanet to colonise and so on. Astronomer Michio Kaku said that we could be a Type 1 civilization in 100 to 200 years, a Type 2 in a few thousand, and a Type 3 civilization in 100,000 to 1 million years. Anyway, back to Tabby star. An alien megastructure, or Dyson sphere, is one possible explanation for Tabby star. It was also suggested that maybe Tabby star was still a young star and still had an accretion disk or a protoplanetary debris disk, a large cloud of dust and gas that orbits the star, usually a young star. Or maybe the star had formed planets and maybe they had crashed into each other. The problem with this is that both of these scenarios involve the star being young, and Tabby's star didn't give us any hints of being young. Not only that, but these two situations involve a lot of dust, and the dust would be hot from the star's light, and we haven't detected any dust. The more boring explanation, but the most likely at the moment, is a swarm of comets that possibly broke up into dust and gas, and so dust and debris are blocking light from the star at random. The problem against this explanation is that there would need to be a lot of comets or large ones. And not only that, but a large swarm of comets doesn't explain how the star has been getting dimmer overall since 1890. There are other proposed explanations, such as the star eating a planet. Maybe there is an asteroid belt that has a lot of material. Perhaps a planet is dragging a lot of material with it. Maybe something just happened to pass between us and the star. But all of these explanations lead us to the same conclusion, which is that we just don't know. If you enjoyed this video, check out my most recent video or this playlist. Also, remember to subscribe for more content. Thank you so much for watching. I'll see you later.